This question is minimum swap to make string equal. So you are given two strings s1, s2 are equal lengths consisting of letter x and y only. Your task is to make these two strings equal to each other. You can swap any two characters that belong to different strings, which means swap I and j in both strings. Return minimum number of swap required to make s1, s2 equal. Otherwise, still return -1 if it's not possible to do so. So you can see in the first example. So here just only one swap one time to make two string equal, and then here swap two times to make two string equal, and then here it's not possible to make two string equal. So that's why here return -1. So I would say, okay, you can see JP Morgan and this company. If you had JP Morgan interview, I think you need to prepare this one. And then now here, I provide three example here. This question a little bit hard to explain, but I will try my best. And then this question actually is gradient algorithm. So for example, so if we swap these two position, what happen? We will get y. Sorry, yeah, y. I guess. So we should swap one time to make two string equal, right? So actually, they have one formula we can remember. So we have di, and d1. The di means if here, okay, here have xy, if we find out, okay, both characters not same, and they follow x in the above and the y in the below. So we will say, okay, the d1 increased by 1. Okay, now we point in the second position. So we know d1 need to add one more. So when we increment d2 is xy. If you see this format, okay, you just increase here by 1. But so here, finally, here's 0. So you can find out here the d1 is 2, d2 is 0, which means all time, right? 2 is sorry, it's not all, it's even time. 0 also even time. If you see the both even, which means what you just do one thing, 2 divided by 2, you get 1, and the 0 divided by 2, you get still 0, right? So now we say we should make just do one swap to make two strings equal. Now let's see the second example. So now you can see it's xy, right? It's d1 and the d2. Because the first pair is xy, so we'll say increment by 1. Now the second point you can see here is yx. So now we need to add d2 by 1. So now you can see, now here is not even, it's o, right? If you find out o time and the o time, both o time, which means we need to swap two times to make two strings equal. So let's see, 1 divided by 2 plus 1 divided by 2 plus 1. So you can understand if the both odd, so you need to follow this. You need to follow this one, this formula. If both even, so you just follow by, if both even, so you just follow by d1 divided by 2 and the d2 divided by 2. Yeah, you just follow this formula. In different test case, we use different formula to get how many swap we need to make. And now let's see here in the third example. Now we also have D1 and D2. So now we can see, okay, in the first one, the both characters are same. We don't need, we skip this one. Now we go to the next. So now it's XY, right? It's XY. So now here increment by 1. Now here also XY. We need to increment by 1. So YX, okay, now D2 increment by 1. So now we find out 3. Sorry, it's here it's not 1 plus 2, it's 1 plus 1, right? So now finally here again a 2, the D2 is 1. So now in the third test case, if the 1 is even, the other one is odd. So which means we cannot make, no matter how many times we swap, so we cannot make two string equal. So for example, so now we swap these two position. Let's see. Okay, XY, XY, and the XY, X. So you can find out the first two pair are equal. So no matter how many times, you cannot make these two equal, right? Because y, it's because y only occur one time, x also occur one time. So you cannot do anything now. So the third test case is maybe the D2 occur one time, D1 occur 2 times. So no matter which one, only 2 test case we can make string equal, the both odd or both even. Otherwise, other test case we can say, okay, we cannot make the equal. We cannot make two string equal. So now let's try his Grady algorithm. So now let's start this question. Start the coding. So now if 1 not equal to 2, we need to return -1. Now we also need to x miss equal to 0, y miss equal to 0. Now we need to go through this one. Because both strings are same length, right? So now if x1 try I equal to x and s1 I equal to y. So it's not s1, it's s2 and it's I. So we will say s miss otherwise. So now s1 dot chart I equal to y and s2 okay. Okay, sorry. So it's x, right? Now we just say y miss. Now we need to see x miss plus x miss, right? Plus the y miss. So mod by 2, you still get 1. If 1 is remainder, we can say we cannot make a two string equal. So we just directly return -1. And then we need to y miss divided by 2. And then if x miss 2, so while here we do one more operation here. So x mod by 2, which means it's O, right? If O, which means need to make 2, we need to swap 2 times, and then we can make two string equal. Now finally we return the rest. not next, returned it. You can see pass on the test case. It, it's here only one, right? So I would say the time complexity is b of n. Space complexity also is b of 1 because I didn't use HR memory here. So thank you for watching this video.